Hi guys, as you can see, I'm still home, nothing I can do. I would rather be at work, but it is what it is. So what I'm going to do is start in chapter 4. I'm going to show you a few examples. Chapter 4 is probably the famous last words, but possibly the easiest one in Pure 4. We're going to be looking at binomial expansion when the index, when the power of the bracket is fractional or negative. So it's just basically a formula, and it's substituting in the formula. That's all it is. Okay. So, and the formula is given to you in the exam. So there you go. Nothing particularly complicated. So I'm going to switch to Notability, do a few examples, take notes, pay attention, and away you go. See you. Okay, guys, so here we are. Binomial expansion you did in Pure 2. So binomial expansion, all it is using the formula. So what happens is the formula you use in Pure 2 doesn't work when the index of your binomial expansion is either a fraction or negative, which is basically that bullet point there. So instead of using the formula that you learned in Pure 2, what you have to do is use this modified formula here. And that is it. All you have to do is use that formula. Obviously, things get a little bit more complicated later when we may do two binomial expansions together or something else, but we're going to go one step at a time. So first example, we got it here. Find the first four terms of the binomial expansion 1 over 1 plus x. So all I have to do is rewrite 1 over 1 plus x as 1 plus x to the minus 1. And I'm just going to use the formula. I need to identify what x and n are. N is the power, so n is minus 1, and x is x. And I make that distinction because there's a common mistake that I will highlight in the next example. So here we go. Just stick it into the formula, which I've highlighted in green up there. So the first four terms is going to be 1. The first term is 1 plus nx. Well, n is minus 1, so minus 1 times x. That's the second term. The third term is n, which is minus 1 times n minus 1, so minus 1 minus 1. So minus 2 over 2 factorial and then x squared. That's the third term. Well, 2 factorial is just 2 times 1. Right, and then 1, 2, 3, and the fourth term is going to be plus. And you got the example down here, but I'm just doing it for you. And the fourth term is going to be n, which is minus 1 times minus 2 times minus 3 over 3 factorial x cubed. And all I have to do is tidy up the algebra now. It's simple enough. So I've got 1 minus x, because the plus and the minus. Minus 1 times minus 2 is positive 2. 2 divided by 2 factorial is just 1. So plus x squared. And then numerator of the fourth term here is going to be minus times minus is a plus, times minus is minus. 3 times 2 is 6. 6 divided by 3 factorial is 3 times 2 times 1. So 6 divided by 6. So I get a minus 1, so minus x cubed. And I am done. That is the first example. Okay, guys, so here I am just going to do exercise B. And funny, I'm actually doing it for the second time because I got it wrong the first time because I made the mistake that I actually said in the video you shouldn't make. So there you go. This is why it is important to pay attention to what I say and do as I say, not as I do. So let's do it. Okay, I'm going to do the binomial expansion of that up to and including the term in x cubed. So the first step always is to rewrite that as a binomial expansion with a negative or a fractional index. In my case, if I rewrite that, I get 1 plus 4x to the minus 2. And then in here now I need to identify what n and x are. N is going to be minus 2, and x is not x. X is actually 4x. So whenever it says x in the formula, I have to write 4x. And this is what tends to trip people up, and that's what tripped me up in my first attempt at doing this question. Go figure. So here we go. Binomial expansion, first term, 1, always with a 1. 1 plus nx. Well, n is minus 2, but it's not x anymore. It is 4x. So I'm going to write 4x. And then plus, then n, so minus 2 times n minus 1, so that's going to be minus 3 over 2 factorial. And now x squared, but remember it's not x, it's 4x squared. And then the final term in x cubed is going to be plus minus 2 minus 3 minus 4 over 3 factorial, and then 4x cubed. And now it's just tidying up the algebra. So 1, 1, plus minus 2 times 4x, so that's going to be minus 8x. All right, then minus 2 times minus 3 is actually positive 6. 6 divided by 2 factorial is 3, and then 3 times 4x squared is 4 squared is 16 times 3, so 48x squared. And the last term is going to be a negative, because minus 2 times minus 3 times minus 4 times it's just going to be negative. Excellent. Then I get my calculator out and I just do 2 times 3 times 4 equals that, divided by 3 factorial. 3 factorial is 3 times 2 times 1, so it's 6. Divided by 6 is 4. And then 4 times 4 cubed, 4 cubed is 64. So 4 times 60 is 256 x cubed. And this expansion is only valid for the modulus of 4x being less than 1. So that means that my expansion is only valid for values of x smaller than 1/4. And I'm done. That's it. You need to write this. Thank you. Okay, and I should just say as well, I just, at the end of my last example, I should have finished with modulus. I forgot to put the absolute value around the x, okay? It should have been absolute value of x less than 1/4, okay? Just to make sure of that, don't get tripped up with that. Excellent, I've corrected that. Moving on. Guess what? I am also doing this thing for the second time, so go figure. It's just tricky. This is just tricky. Just keeping track of things. That's the only problem. All right, so moving on. Let's do the final example. And this does trip people up as well. It's tripped me up for the same mistake as before. Anyway, so find the expansion of square root of 1 minus 2x up to and include the term in x cubed. Let's worry about the first bit first. So always rearrange the thing as an expansion with a negative or fractional index. So I've got 1 minus 2x to the power 1/2. So n is 1/2, and it's not x, it's minus 2x. You need to be careful with that. Right, so that's it. Once n is 1/2, and I know that the other bit is minus 2x, let's stick that in the formula. So here we go. 1, 1 plus n is 1/2 times x, but it's not x, is minus 2x. Okay, careful there as always. Plus n, which is 1/2, times n minus 1 minus 1/2 over 2 factorial, and then x squared, but it's not x, is minus 2x squared. All right, and the next term plus, so n 1/2 minus 1/2 minus 3/2 over 3 factorial minus 2x cubed, and then tidy up the algebra. So 1 is 1, it's going to be minus 1/2 times minus 2, so yes, minus x. And then the next bit is going to be negative as well, isn't it? So minus. Right, 1/2 times minus 1/2. So 1/2 times 1/2 is a quarter. A quarter divided by 2 factorial. A quarter divided by 2 is 1/8. So 1/8 times minus 2x squared is going to be, minus 2 squared is 4, so minus 1/2 of x squared. And the final term is going to be a negative again, take away, because 1/2 times minus 1/2 times minus 3/2 times minus 2 cubed, this is going to be negative. So then 1/2 times 1/2 is a quarter times 3/2 is 3/8 divided by 3 factorial, which is 6, is 3/48 is 3/48, but that actually, well, anyway, 3/48, that could be divided by 3, but I'm going to leave it there like that. So it's 3/48 times minus 8x cubed. So that's again minus 1/2 of x cubed. And the expansion is only valid for modulus minus 2x less than 1, because I've got an absolute value function there, the minus doesn't matter. So this is only valid for modulus x less than 1/2. Okay, and that's part A answered. Well done. You should copy this expansion down because it's important for the next part, which says, by substituting in x equals 0.01, find a decimal approximation to square root of 2. Now, the classic mistake here is that you take 0.01, sub it into there, and that's your answer. But that's really wrong, okay? That is really, really wrong. So, what we're going to do is the following. You have to substitute 0.01 in both sides of your equality. So what we actually have is that we have that the square root of 1 minus 2x was approximately equal to the expansion that we came up with. So 1 minus x squared over 2 minus x cubed over 2. That was our expansion, right? Now, I should substitute 0.01 in both sides of my equation here. So what I've got is the square root of 0.98, because 2 times 0.01 is 0. So okay, that shouldn't be a problem. And that's going to equal, I'm not going to do it here because it's a mess, but you got a calculator, you can do it. But all of that is going to be some value. I'm just going to use that red line. Whatever value you get from correctly substituting 0.01 into this expression here, whatever value you get. Now, you're wondering, but I want to find square root of 2. Where is that coming from? You need to be a little bit clever here and a little bit of, manipulate. Square root of 0.98 is the same as the square root of 98 over 100. And that's approximately equal to whichever value we found before. And this is root 98 over 10 is approximately equal to the value, whatever value we had from before. Now, being clever here, root 98 is actually 7 root 2. That's where the root 2 comes from. That's approximately equal to whichever value we found before. And all you have to do now is rearrange and say that root 2 approximates whichever value we found before from substituting 0.01 into the right hand side of the equation, if you want to call it, and then times 10 over 7, and that would be your approximation. There you go. It's taken me 2 times to do it, but I got there in the end. Pay lots of attention with these. Go through the example yourselves, copy it down. Best of luck. Email me a screenshot of any questions you may have. I'll try to answer as soon as possible.